Hi grade 12s. Today we are going to be looking at the logarithmic functions. They have only the vertical asymptote. Remember, the exponential functions have only the horizontal asymptote, which is the y value. So they've got the vertical asymptote, which is they include the x values. So we need to look at how the graphs will look like. Okay, here y equals to the log of x. Here the log here, just next to the log there is positive, which means that y is positive here when the log is positive. And the x inside here, when x is positive, it means that x is positive. So here when the log is positive, it means that the y is positive and the x is negative. Here y is negative and x is positive. Here both y and x are negative. Okay, this Cartesian plane here, this is y-axis and x-axis. This graph goes up in the territory whereby the y's are positive and the x's are positive. So here in this portion, both y and x are positive. So whenever you are given the equation whereby here next to the log, on the left hand side of the log, if there is a positive sign, then it means that the graph will be going up, trying to reach the positive values of y. And then if the x is also positive, when the graph is going up, it will shift on the right direction for the x values which are positive. So also here you can see that here the values of y are positive, but of the x are negative. So the graph will go like this for the negative x's and the positive y's. So the graph will go up for positive y's and go to the left hand side for the negative x values. So I think it's clear. And also here y is negative, so the graph will go down wanting to reach the negative values of y, but will go to the right hand side wanting to reach the positive x values. And also here they are both negative, so the graph will go down wanting to reach the negative values of y, and also to the left hand side looking for the negative values of x also. So that's how you're gonna figure the graphs. So whenever you are doing the problem, you will calculate until when you are now ready to draw a graph, look at the equation again, and then you will imagine how the equation will look. You will be knowing exactly that the graph will look like this, or like this, or like this, or like this, according to how the formula or the equation is. The logs, you have to have an idea of the logs themselves. So we know that the log of 1 is always equals to 0, regardless of how much is the base. The base can be 5, can be a log of any base. Any base can be 2 or 200 here. As long as it is the log of 1 here, the answer is always 0. This log of 1 is always 0. The answer is 0. And also if there is the log like this, the log of maybe base 2 and it's log of 2 base 2, it's always equals to 1. If the log and the base they are the same, 2 and 2, then the answer is always 1. Why is it 1? This log of 2 base 2 is like here. It is like it's a log. You can write it this way if you like. It's log of 2 over log of base 2. Log base 2 over log base 2. The answer is 1 because what? This log 2 will cancel this log 2, and the answer will be 1. And so also even if it's log of 10, any base, as long as it's maybe 10 log of 10 base 10, log of 10 base 10, then the answer is 1. Always as long as the base is the same as the number that is inside the bracket, the answer is always 1. So I think it's clear here. Always when it's the log of 1, regardless of what is the base here, the answer will always be 0. So keep in mind all that, because we are going to be needing it as we move on from now on. That's just a basic information about the logs. So now let's say that we've got y equals to the log of x base 2. Okay, like we did on the exponential graphs, we will do the same thing here. We start by saying this x will be equals to 0, and then equals to 1, then equals to the whatever base is here. First of all, x will be equals to 0, then x equals to 1, then x equals to whatever base. If the base here was 5 here, then we'll say x equals to 0, x equals to 1, then x equals to 5 if there is 5 here. So the last one is whatever the base is here. So we'll do it in practical. First of all, we say x will be equals to 0, and that x equals to 0 is your VA. Remember that we are dealing with VAs here in the logarithmic functions. Unlike in the exponential functions, we were dealing with the horizontal, but here we are dealing with the vertical asymptote. So our VA is x equals to 0. And then another one will be x equals to what? We said another one will be x equals to 1. Then x equals to 2. This 2 is not like saying 0, 1, 2. No, this 2 is whatever base we have, and in this case we've got 2. So keep in mind that it's not like just it's 0, 1, 2. No, it's 0, 1. Then you put here whatever base is there, right? Keep in mind that it's not like the exponential function whereby you just do it in the ascending order. Then now we are able to draw a table. So drawing a table, what are the values to put on the table? The values to put on a table, okay, this is x and this is y. Now the values to put here, it's 1 and 2. This 1 and 2. You don't put the VA. You always don't put in the table. You put the other values, which is 1 and 2. Like as usual, you substitute the input values from the original equation and get the output values from that. Then we will say our equation is y equals to log of x. Log of x base 2. Log of x base 2. Then we substitute x. We put y where there is x. And then we'll get something like log of 1. We'll get log of 1 base 2. We said that the log of 1 here we said, remember we said the log of 1, any log of 1, regardless of what the base is, like here, is always equals to 0. Just because I told you that, then we have to apply it here. So our y here will be equals to 0, and then we put 0 here. Then we substitute also 2 from the original equation. We substitute 2 and we'll say y equals to log of x. Log of x base 2, the log. Now we will substitute 2 where there is x. So we'll have log of 2 base 2. Remember we said that if here in the bracket it's the same as the base, it's like log of 2 over log base 2 over log base 2, which is always equals to 1. Log of any number with the same base is equals to 1. So with that permission, now we are allowed to say that y here will be equals to 1. Then y is equals to 1. Now that we've got 2 points, we only need 2 points to plot the graph. We can be able now to plot our graph. Our graph will look like this. We've got, first of all, we need to know what is our VA. Our VA in this scenario is 0. So VA goes like this. VA is not like HA. VA is vertical because it's a vertical line. HA is horizontal. That's the difference. And VA, it cuts in the X values. It can cut here in the X values. Then HA cuts on the Y values, can cut at 0 Y value or negative Y value. But here we are dealing with the vertical asymptote, which is, in this case, it is equals to 0. Our VA is equals to 0. And then let's look another point now, where X is 1, Y is 0. So where X is 1, let me start by writing the numbers here. X is 1 here, X is 2 here, and then Y is 1 here. So we said where X is 1, Y is 0. Where X is 1, Y is 0, right? And then where X is 2, Y is 1. Where X is 2, Y is 1. That's the point. So the graph will go like this now. That's how our graph will go. You can actually see that this graph is this one. Is like this equation, because Y is positive and X is positive here. So Y is positive and X is positive. So the graph must go like this. That is why the graph went like this. I think it's clear here. And then we can look for the domains. Now the domains of this one, they differ now because now the domains will be like this. Okay, the domains are the minimum value of X, from the minimum value of X to the maximum value of X. And here the minimum value of X will not from the negative infinity to infinity, but the domain, but it will be from it will start from what? From the vertical asymptote. What is the vertical asymptote? Vertical asymptote, remember, it is 0. It is 0. So it's here where X is 0. So the graph starts where X is 0. X is 0 here. It goes up and up to infinity. So from 0 up to infinity. So which means from 0 up to positive infinity. That's our domain now. It's not like in the exponential whereby it's from negative infinity to positive infinity, and also in the quadratic equation. It's not like that in the logarithmic functions. So and also there is a change in the range also, because now the range now is from negative infinity, because we don't know where the negative Y values it comes from here, until the positive infinity of the Y values. So the range now is from negative infinity up to positive infinity. We don't know where it ends there according to the Y values, and we don't know where it started from negative infinity to positive infinity. So I think it's clear with the domains and the range. And once again here we need to know that the range are for Y, and the domains are for the X values from the minimum to the maximum ones. Let's do another example now. We can just do the example that fits this graph. Let's do the example that fits whereby Y is going to be positive and X is going to be negative. Right? Let's say now we've got Y equals to the log of base 2 again, log of base 2 into 3 minus X. Close the bracket. Okay, here we also don't have a vertical asymptote. To have a vertical asymptote, you need to have then plus something here or minus something here. So keep in mind that we will have maybe one example whereby we will have also the vertical asymptote. So, but for now we don't have. So another thing you have to notice here, this thing must be, negative x plus 2, but they can trick you and start by positive 3 minus x. So it's like this thing is it's a log of negative x plus 3 base 2. So, but they can write it like this, but you know that you are looking at the x itself. You are not looking at 3. To figure out that x will be negative, you look at x, the sign of the x, not the sign of the constant number inside the bracket. No, you just look at x, negative x. If the x is positive, then x will be positive. But if it's negative, then it means that it's a negative x graph. So keep in mind that this thing can be written like this, negative x plus 3, but they just chose to write it like this, positive 3 minus x. But it's the same thing, positive 3 minus x. Just to keep in mind, I gave you this problem on purpose so that you be familiar with some of these tricks. First of all, we say x, what is inside here equals to 0, which will be our VA. Always, first of all, when you say everything that is inside the bracket equals to 0, that is a VA. And then the next ones are just for the points of the table. Right, let's go back to our problem, our current problem. Now, we will say now 3 minus x, we will say it's equals to 0 first of all. Like here, we started by saying x equals to 0 because it was only x here inside. But now it's negative x plus 3. So that is why we say 3 minus x all equals to 0. I think it's clear. Now, our x will be equals to 3. Our x equals to 3 because I just took this x, put it here, it will become positive. Then x is equals to 3. This point is our VA, our vertical asymptote. Right, we are having our vertical asymptote now. 3 minus x equals to 1 now, And then our x will be equals to 2. And then you say again 3 minus x equals to whatever the base is. And in this case, the base is 2. Then we say equals to 2. Our x will be equals to 1. So let's go to the table now. This is our x as usual. This is our y. And then what are the points? Our points are 1 and 2. Y equals to the log of 3 minus x, and then we've got log of 3 minus 1, which is 2. So log of 2 base 2 is 1. We know that. Let's just write it for your benefit, right? Log of 2 base 2. You remember we said log of 2 base 2 is 1. Log of 10 base 10 is 1. Now our y will be equals to 1. So we put 1 here where x is 1, y is also 1. And we'll again say that y will be equals to the log of 3 minus, now we substitute 2 minus 2. Then we will be having log 3 minus 2 is 1. Log of 1 base 2. Remember the log of any one base, whatever base we don't mind, is always 0. So our answer here will be 0. Our y will be equals to 0. And so here it is 0. Okay, now we are having 2 points. Then we are able to plot our graph. We've got 1 here, 2 here, and 3 here. Okay, what is our VA? Our VA is 3 now. Our VA is not 0 now. It's 3, vertical asymptote. And then looking at the points where x is 1, y is 1, which is this point where x is 1, y is 1. And where x is 2, y is 0. Where x is 2, y is 0. And we are expecting a graph like this, because x is negative and y is positive. And x is negative, y is positive. We expect the graph to go like this. Right, let's do it. That's our graph. Now that's our graph, and the domain. What are the minimum values of x and the maximum values of x? The minimum values of x, they start from the negative infinity. We don't know what are negative x's here. From negative infinity all the way to this to 3, to the vertical asymptote, which is 3. It's where our x's, they end, the values of x, they end here to the vertical asymptote, which is 3, from negative infinity. Now that is why now we will have from negative infinity, which is the lowest value of x's, then up to positive 3, up to here. It's square bracket because it's where we are sure it is ending. If it's infinity, we put small bracket because we don't know up to which number, right? And then about the range are always from negative infinity to positive infinity. Even if you don't look at the graph, for the range, they are always from negative infinity to positive infinity. We don't know what is the minimum negative value of y here, and we don't know what is the maximum y going up there. Let's do the last one before the video becomes very, very long. Some kind of a tricky one again, but I'll tell you. Y equals to 3 minus log. Y equals to 3 minus log of 5 minus x base 4. We've got y equals to 3 minus log of 5 minus x base 4. Okay, here again they trick you. They should say that it's y equals to negative log of negative x plus 5 and then plus 3. This thing is like this. It is like y equals to negative log of negative x plus 5 plus, see now, you see what is going on here. This thing is like, it's y equals to negative log of negative x plus 5, base 4 plus this 3 here. This 3 could go this side, and this negative x could go this side, and 5 this side. So keep in mind that it's like this is this one. This is whereby both y and x are negative. Both y and x are negative. So even if it's here, you can read it quite simply. It's y is negative and x is negative. You don't have to change it like that. But if you like, you can rewrite the formula like this. But for me, I won't change it. I refuse to change it. Right, and then we will just use this formula that we are given. We're not use this one. We're not using this one. Right, we are having 5 minus x equals to 0 first. That will give us our v, vertical asymptote, of which x will be equals to 5. X will be equals to 5. That's our VA. And then again, we will say 5 minus x equals to 1. 5 minus x equals to 1, of which our x will be equals to 4. That's another point on our table. Then also we'll say 5 minus x equals to 4 now. Remember, we said we start by saying whatever inside the bracket equals to 0, which will give us our VA. And then whatever inside the bracket equals to 1 now. Then on the third time, whatever inside the bracket now equals to whatever base. Previously, the base was 2. Remember, the base was 2 here. That is why we said x is equal to 0, or x equals to 1, and x equals to 2, which was the base. Same thing here. We said equals to 0, equals to 1, then equals to 2, which was the base. And here our base is 4. Right, I think it's clear. Then our x will be equals to 1. Then we can draw a table. We've got 1 and 4. I told you we don't use VA on a table. We just use other points, which is 4 and 1. And let's just start by the smallest one, which is 1. and then 4, right? Then we substitute these input values from the original equation to get the output values. Y equals to 3 minus log 5 minus x. Then it's 3 minus, inside, if we put 1, 5 minus 1 is 4. So which means we've got the negative log of 4 base 4, which is positive, which is negative 1, because base 4 of 4 is just 1. So minus 1 here, 3 minus 1. So 3 minus 1 will be 2. So our y here will be 2. Then then again we substitute 4 now. Now we substitute this 4 from the original equation also. We will say now y equals to 3 minus log of 5 minus 4 now. 5 minus 4, because here we substitute 4 where there is x. Where there is x, we put 4. Then with confidence now we can say that here we've got 3 minus 0, which is remaining as 3. Then we've got 3 here. Then we can be able to plot the graph. We've got 1, 2, 3, 4, 5, right? Terrible 5, right? Okay, then here on top we've got 1, 2, 3. 1. What do we have here? What is our VA? Our VA is 5. This is where our graph will start. Remember, we are expecting the graph like this because it's both negative y and negative x, which is negative y and negative x, which is negative y and negative x, which is negative y and negative x. We are expecting something like this. Then what are the points now? We've got where x is 1, y is 2. Where x is 1, y is 2. Then another point where x is 4, y is 3. Where x is 4, y will be 3. Then we've got this kind of a graph. This is the kind of graph that we have. Now, what about the domains? The domains for this one now, it will just look at the x values. The minimum x values are the infinity, because we don't know what negative x is there. Up to what? Up to the vertical asymptote, which is 5. So they end here at 5, the values of x. So which means we've got negative infinity up to what? Up to positive 5 here. The range will be very, very simple. The range will be from negative infinity to positive infinity. That's all for today. Thank you very much. We didn't do the one with negative y and positive x. We didn't do that one. We just did this one. We did this one and this one. This one you will find the problems which are like this, and you are able to do it because you know all the methods now. It was just for your benefit, but now you know how to handle it. At your question papers, they can ask you in any way. They can give you the equation like this, and they draw the graph, but maybe they don't put the numbers here. They don't put 1 or 2 or what. And maybe they can say that maybe they put A here and B, and they say find the coordinates of B or the coordinates of A. Then you know how to find them. You just go back, you go to these steps and do whatever they need according to whatever we did here. We do all this just because we want you to be able to answer any trick question that they can ask from any diagram they can give you. So thank you for watching. Keep well.